Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSPmagazine. You're listening to a new Redefining Security podcast. Have you ever thought that we are selling cybersecurity insincerely, buying it indiscriminately, and deploying it ineffectively? Perhaps we are. So let's look at how we can organize a successful InfoSec program that integrates people, process, technology, and culture to drive growth and protect business value. Knowledge is power, now more than ever.
Imperva is the cybersecurity leader whose mission is to protect data and all paths to it with a suite of integrated application and data security solutions. Learn more at imperva.com.
Asgardio by WSO2 is a developer-focused identity and access management solution. Offered as Identity as a Service, or IDaaS, Asgardio by WSO2 creates seamless login experiences to your apps in minutes.
Hello, everybody. This is Sean Martin, and you're very welcome to a new Redefining CyberSecurity podcast here on ITSP Magazine. And sometimes I'm joined by my co-founder, Marco. He's off in space somewhere doing some other things. I'm flying solo today in the atmosphere somewhere, and I'm joined by two guests who are going to talk to us about satellite security and probably broader space security as satellites connect to that. And Marco and I have had many conversations on this topic, where satellites don't just play a role in space, but also in terrestrial activities and maritime activities and a bunch of things. So they have a hand in a lot of stuff, which I'm sure our guests today will share with us. And on the show, we have Logan Finch and Jason Williams. Thanks, guys, for being on.
Thank you.
Thanks, Sean.
So very quickly, maybe just a few words from each of you so folks know who they're hearing from, what you do, why you do it, and why specifically Hackasat is something that you're so interested in. Logan, you first.
Sure. So I'm the technical lead for the Hackasat CTF at Cromulence. That's the company that Jason and I both work for. Jason's the CEO. And I'm an engineer that's working on the Hackasat CTF. My background is in aerospace engineering. I was brought on to Cromulence to build this CTF, which creates a CTF around space systems and space cybersecurity. So my background being in space, I understand space systems from a holistic level. Ground system, the satellite, and kind of everything in between. So then I came to Cromulence, which is more of a cybersecurity company, to help them build the CTF and make it realistic in terms of how it maps into realistic systems.
Yeah, and I'm sure we'll touch on that because that's probably one of the biggest challenges is putting this stuff in the hands of people who need to test it to see where the boundaries are and how those boundaries can be exceeded and the systems be misused for nefarious purposes. Jason, a little bit about yourself.
Yeah, like Logan said, I'm the CEO of Cromulence. Just a little background, Cromulence is a national defense contractor specializing in cybersecurity for the U.S. government. A little about myself. I've been doing cybersecurity for a little over 15 years now. Started as an electrical engineer and a software engineer, and then found my way into securing software systems, evaluating software systems, assessing them, and then co-founded this company around it with a specialization really in space systems, embedded systems, and so forth.
Love it. And I don't know who wants to take this, but what I'd like to do first is maybe just get an overview of what's involved with a satellite system. And we can connect it to space exploration to start. And if you want to touch on some of the other things that I mentioned, like maritime or or weather, which is an important topic at the moment, we can certainly go there. But what's involved? Because I can picture ground-based systems and in orbit-based systems. I don't know if there's anything in between. Obviously, the communications, there's software and sensors and all kinds of stuff. Maybe who can give us an overview what's involved in this whole picture?
I can grab that one, Jason, if you'd like.
Sure.
So space systems from a high level. Well, first you have the satellite, right? That's the kind of the obvious part that everybody thinks about. The satellite's in orbit around Earth. Depending on what the mission of the satellite is, there's a lot of different orbit types that provide different geometries for different missions, and allow the satellite to do whatever it's up there for. And I guess in this we'll kind of scope it down. We're talking about satellites going around Earth rather than other spacecraft that might be leaving Earth and going to Mars or something like that. But I digress. So for satellites, we're orbiting around Earth. They're doing their mission. Well, that's just a very small part of a very complicated system. The satellite itself, obviously, a complicated embedded system. A lot of them take years of development. At least traditionally, the big some of the larger satellites that are up there, thinking things like GPS and weather satellites. Those are large vehicles that have gone through a lot of development. They have to work. Then there's these whole new round of satellites, all these small satellites, CubeSats sometimes you'll hear, small satellites, nano satellites, or smaller satellites. And there's a lot of startup companies that are building these to do missions at much cheaper than previous missions were able to be accomplished. They may not have the exact same capabilities as these large systems built by governments or large contractors, but they're much cheaper to produce and build. So that's the space side of things. Then you have the link going up and down, so it's some sort of communications link. Usually, traditionally, that's been over radio, so RF links. People are investigating using more advanced things like lasers and stuff like that for higher data rates in the future. That's all been done. It's just not necessarily the primary way that most satellites are controlled. Then for most systems, you have a large amount of software and system running on the ground. So you have whatever's controlling the satellite. So there's some sort of system or software that can send commands and receive data from the satellite, retrieve the mission data. So whenever the satellite's up there, it needs to send down its data or uplink files or configurations to modify the behavior of the satellite. And all throughout this entire kind of chain, there's cybersecurity issues at play. Some of them are really obvious, and some of them are much less obvious, but still equally important. And traditionally, the space industry has kind of, relied on security through obscurity and some, we're not that interesting. Nobody's going to be going after us type stuff to avoid, a lot of cybersecurity practices. But I think that's, changing really fast right now.
And as you're describing some of those elements, I couldn't help think about industrial control systems and critical infrastructure, which perhaps this even fits in as a category. And a lot of those systems, SCADA systems, for example, weren't originally designed to connect to things or the internet more specifically. And that poses a lot of problems. This sounds obviously like it has a connection design built in from the ground up, but you just mentioned that it's security through obscurity is kind of the main method. What challenges do we have going back if that's the case? If security wasn't built in by design, what challenges do we have going back to kind of fix some of these things?
I think, Sean, you brought up some interesting analogs. Obviously, industrial control systems have some similarities there. One of the ones that we've found with space systems is just the lifespan of these vehicles, the lifespan of the operations, the systems involved, and things like that. So you have you have NOAA weather satellites that have been in operation for 20 years in some cases. You got to think about the state of cybersecurity 20 years ago, or even at the time at which these vehicles were designed. We're talking like Windows 98 time scales here.
I was going to joke when 95.
You're going to go back that far, but things in cybersecurity, just general concepts, defense measures, certain things like that, these concepts didn't even exist back then. So we have systems that are in operation today that are running without any of these kind of security protections that we take for granted today on like desktop class systems and server class systems. And that's kind of true in the ICS world as well. You have industrial control systems that are still in operation. If it isn't broke, don't fix it kind of mentality. And then you've got them hooking up to the internet. Whereas satellite systems, they were hooking them up via RF communication links and multiple ground sites being connected to each other, either through SATCOM terminals and even sometimes, analog phone lines, over dial-up modems, that sort of thing. And so there's just a lot of challenges there with those systems because, are there the budgets there to modernize them, to protect them? And how do you fix a system or secure a system that's already in operation, that's in space, right? So a lot of the concepts that we're visiting in Hackasat is about designing secure systems, but also about bringing into that thought process about as you're designing these systems, how do you make them future-proof? Throughout the lifespan of those vehicles, and that's something the community at large, the aerospace community at large, wasn't really thinking about probably when they were designing these vehicles 10, 15, 20, 30 years ago in some cases.
And forgive my ignorance here, but I'm going to ask anyway. What's the oversight landscape look like? I presume there's a lot of government entities building these things, and certainly commercial entities building these things. I don't know if the people that are building them are also running and managing and maintaining them. Is there something equivalent to an FAA that kind of keeps track of who's doing what? And I don't know if it's not just managing the location of the devices, but who's running the overall oversight? Is there an overall oversight? I would think NASA is a good example, but I doubt they're looking at every satellite.
Yeah,
certainly not on a global perspective either.
Yeah, you got to think about that from an international perspective, not just from from what we do maybe in the United States, right? I know there's certain standards for like the communication links, like you have to adhere to like FCC filings and things like that for different bands of operation. But and obviously to the vehicle design parameters, just to make sure the vehicle will survive in outer space, which is a pretty hostile environment. But I mean, maybe Logan, you can elaborate on if there's standards beyond just the vehicle specs and the communication links and things like that. I'm not aware of too many, but Logan would probably be better suited for that question.
I'm sure. So overall, there's really not like a standards organization or even a piece of the government that says that's responsible for making sure everybody operates their satellites safely. Especially in this age where anybody with some money can build a small satellite, contract a launch, and launch them in mass. So I think like Jason said, the radio sides of things is regulated by the FCC. So you can't just transmit data up to a satellite without having licensing. That's in the U.S. Outside of the U.S., you might be dealing with the regulator for another country. And all this, to my knowledge, is all kind of managed with some UN treaty kind of stuff that is not really enforceable. So as you can imagine, there's probably good actors and bad actors in the way that these space systems are being operated and maintained. From a security standpoint, there's definitely nobody I know that's saying thou shalt build systems this way. At least in the commercial side of things, I think commercial companies are adopting security practices because it's in their commercial interests to do so. It's it's not any government entity saying that they should do it. And then on the government side, that's a whole different game. And I think that depends entirely on on the agencies and who's running it, on how that's all handled.
Yeah, it's a very complex problem because it's space is a shared domain for multiple nations, right? And so whatever standards we might come up with within the U.S., getting broad adoption across the international community is going to be a challenging thing. I do think there is some push for that, obviously. In light of like recent events and just the trend, like the Viasat hack and so forth. But as far as I'm aware today, there's no adopted standard like cybersecurity standards for space systems that exist.
And yeah, I want to touch on the technology in the vehicle in a second, but just sticking with this kind of an oversight view. So you mentioned there's no real security companies looking at this. And I'm familiar with having many conversations, obviously, on this podcast. I'm familiar with dedicated rail system security. I don't know if it's an ISAC. I can't remember exactly that point. Yeah. But there are companies building, or at least analyzing the risk in the railway space, and then building products to help secure them. We know in ICS there's been a lot of interest in that in the last few years, and companies coming up for that. What's space look like in that respect? And satellites more specifically, even.
Yeah, I think there's probably companies out there looking at it, but I think for the vast majority of companies, it's the companies that are manufacturing their vehicles are the ones that are, doing the cybersecurity side of things, right? Managing it internally. Whereas I think you're alluding to in certain industries now, we're having third-party evaluation and things like that are occurring. I'm not aware that that's happened, and that's just a general trend. I think in a lot of areas, right? ICS systems, as they became targets, then there was a push for that, so that there was third-party verification. We're seeing that requirement within the DoD and their systems. I would expect that to span into other systems in the aerospace domain as well, over time, as cyber becomes such an important topic for a lot of these systems, become more complex, more integrated, and more communication links that are vulnerable to attack. But I don't know that I answered your question, just because I don't necessarily know the answer to it. So
yeah, that's fine. I was just curious. It's not critical. What I think is more important is to spend some time on how we analyze what's going on. And to be honest, guys, I mean, the satellite I have in my backyard, I'm not going to let anybody play with. I spent far too much on it. So nobody's going to hack my own satellite.
That's a real problem. We actually experienced, funny you said that, Sean, we actually experienced this on Hackasat. So the competition, when we first started working on the competition and designing that competition, we went around and asked within the aerospace community, hey, could we borrow one of your satellites? And went to these companies and within the U.S. government, and the pushback was real. Most I think every company we encountered said, no way, we're not putting our satellite on display to let hackers attack it. And so what we ended up doing for Hackasat is in light of not having a real satellite, we designed our own. An exemplar satellite that was representative of real systems, incorporating software and architecture from real system, just because nobody was willing to do that, right? Like you're now seeing like at DEF CON in the car hacking village, right? Tesla and other car companies are donating cars, and people are able to go to DEF CON and they're actually able to look at these systems. Maybe that needs to be something that the aerospace community considers, bringing some of these, systems to these hacking competitions to light, so that it isn't such an obscure system anymore. It becomes more in the public domain, so that the public and these really resourceful and capable hackers that exist can have a chance to look into these systems and evaluate them.
Yeah, and I'm glad you brought up the car hacking village. I know the Aerospace Village has support from the aerospace industry as well. Primarily, I know this is driven thanks in part to our good friend Steve at the Aerospace Village that put us in contact with each other. But having access is certainly critical. So I was joking, but mainly to make this point that we need the support of industry, right,
Yeah.
and the government,
Yep.
the makers of these things. So tell me a little bit about, I'm not going to go down the risk path because we'll spend too much time on all the things that can happen
Absolutely.
there.
Yeah.
I don't know, HackSat 3, let's talk about the history. What was the original one like? Has the mission changed since the first edition of it? Tell me a little bit about what's going on at the event.
I'll try to go through it quick because we are in our third year, so there's quite a bit of history there. But I think it started some time ago. There was the group of people within the government, and they basically posed the questions: we want to do a competition around hacking satellites, and Cromulence got involved because of our work that we had done prior with DEF CON Capture the Flag. Some of the members of Cromulence were on one of the teams that hosted DEF CON Capture the Flag, myself included, and so we just went out to, I believe we went out to Virginia and the launch site there on the coast, and we all got together and we just brainstormed this competition. And so in the first year, we came up with this concept that we would be hacking back a satellite. So we were, the concept was that an adversary, had hacked the ground station and a space vehicle and had gained control of it, or something like that had occurred. And so year one, the teams were basically hacking through from starting from position of the ground station, attack the ground station, gain control of the ground station, get the crypto keys, then communicate up with the space vehicle, and then pivot through the different components in the space vehicle and regain control. And that was a very scenario-based concept for HackSat 1 finals. So the teams were not in direct competition with each other necessarily. They were all working on independent vehicles that we had built. Basically a rotating environment that rotated about every 15 minutes. And the vehicles were on air bearings floating in these acrylic spheres. And so they had a single axis control authority with a reaction wheel on it. And the final objective of their of the challenge was to rotate the vehicle in the room and take a picture of a paper moon on the wall, and then downlink that to the ground station and submit that to us as organizers to prove that they had done that. I believe one single team, at the last minute was able to do that and get through that. There was a lot of different challenges involved with that. And then we evolved, HackSat into, let's make it a little bit more of a, what is known in the CTF community as kind of an attack defense style game. So there were certain aspects of the game where the teams could actually send commands to their opponent's satellites and attack each other's satellites. And so we evolved the realism of the game with more realistic space systems and so forth in HackSat 2. And then, we got a lot more coming on HackSat 3, but I can't really talk too much. Maybe I'll let Logan field anything there, but that's pretty much the origins of it. And a lot of it came from just, like you said, was bringing that awareness to the community. These systems are vulnerable to hacking, and that we need to secure these systems, and we need to get this cybersecurity community and the aerospace community working together. And that's exactly what teams did to win, as they brought these two different, I'd say, multiple disciplines together to form a team to work through these scenarios. Because this is not just a cybersecurity competition. This is this involves satellites and space systems and so forth. And so it requires pretty capable teams to solve these challenges and to even compete in HackSat at the level needed to get to finals.
Yeah, I love that. Maybe Logan has some additional points here, but I'm just wondering, kind of to that last point, Jason, what is required? Can you take somebody who's been hacking Windows 98 for years, or who manages an enterprise IT stack that is primarily Linux and Microsoft? Does that stuff transfer over?
I think some of the concepts do, but to get to really compete in HackSat, you've got to understand so many disciplines. So Logan can go into maybe all the details, but we challenge across the domain. So it's not just can I assess a software binary or system or something like that. It's orbital dynamics. It's understanding protocols, RF communications. We challenge people, across the spectrum of all these disciplines, which is kind of really unique, I think, with space systems, for the cybersecurity community, because spacecraft are complex systems. They're complex, they got sensors, actuators, they've got, physics involved, there's RF communications, all of these very complex, engineering fields to make these systems work. And so that's one of the elements of Hackasat. Logan, could you just maybe explain some of all the different things, about it?
Sure. Like Jason said, space systems in general are systems of systems. So, your usual terrestrial cybersecurity expert, might be comfortable on the ground network side of a space system. That's going to look a lot like other ground networks, servers running applications, doing normal, IP communications, doing normal things, data processing, all that kind of stuff. Well, then, on the other side, you have, spacecraft experts, people who understand the engineering and hardware for spacecraft. Those people, might understand, the embedded systems type stuff, how different the protocols and electronics and sensors and all that stuff works. Then you have a whole other group of people like the spacecraft operators. These are the people that actually know how to, make a spacecraft do what it needs to do in space. And you need to bring all of these people together to be able to compete at a high level in Hackasat. You need to be able to, and work together. Because let's say you have a challenge where, the binary is a binary running on the spacecraft. Well, you might need to, do something special to even get that binary downloaded from the spacecraft to even start performing analysis on it. And to do that, you need to be able to bring in other experts to be able to help even, operate the spacecraft safely before you'd even be able to, make progress on other aspects of or challenges that are part of the game. And I guess overall, we're trying to, bring complexity into a interesting CTF game where it makes sense to, show the complexity of space systems and highlight, different pieces of architecture, different parts of the systems where vulnerabilities might exist, where, we at least want to make industry and government and all them think, oh, these are things that, we need to be thinking about that are important aspects of security. While also, providing an interesting, game for all these high level teams to play.
Yeah, and Logan, maybe, or Jason, whoever, are there things that folks in the aerospace and satellite space do think about differently, need to think about differently with respect to cybersecurity? I'm just thinking, how many times have we heard the CIA triad, right? Confidentiality, integrity, and availability. Is there a fourth or fifth leg to that? Do folks look at things from like the NIST framework, identify, protect, recover, respond, that kind of stuff? I'm getting in the wrong order, but
for me, Sean, one thing, because I wasn't a space guy, like Logan, for me, that, what I learned a lot about space vehicles, was just the resiliency and the reliability aspect of it. Recovery of the vehicle is first and foremost in space system designers like heads, which sometimes can come in conflict with some of the cybersecurity aspects of it. Like, you've experienced it yourself. Like if you fail to log in 3 times, you get locked out, right? You have to have another way of unlocking it, right? This is just an analogy, just a simple analogy. But, in a space vehicle, if you maybe encrypt the firmware or something like that, and then maybe you have an error in the decryption key or something like that, the vehicle just doesn't work anymore. And so that might be a design aspect that makes it more secure, but it also make it less reliable. So, on to that point, that was one of the things that was really eye-opening to me is you can't just do some of these things, or you have to think about it differently, or you have to make different type of decisions that you would on maybe, ground system components that a human can get access to, or that you have other communication methods to. But on these space vehicles, it's up in space and you're not getting it back. And if you've got a $10, $100 million, $1 billion satellite, something goes wrong or whatever, and maybe one of your security mechanisms kicks in, then you just lost that thing, right? And that's so you want to have backups and redundancy. So that's one thing from me, at least, that I observed.
And does that change how? So certainly it changes how you define the security requirements and policies and implement it, of course. Does that change how the CTF plays out then? I don't know, because it sounds like if I guess the question might be better put as, do we know what some of those policies are? Do we know that there won't be 3 failed logins because we know that will brick the system? Or we know if we won't allow these types of injections to occur because it'll destroy the data and disrupt communications and it'll brick the system. Does it change things like that?
So I think from the CTF side of things, we try and build a system for the game that has realism in those areas where it makes sense. And then where we can, as designers, kind of step back and say, with the system we build first, and then, second, if it's really, difficult to build, those safeguards in, we can always have rules and stuff like that saying, don't be going and DOSing, everybody, because, while you might be able to do that in real life, it makes, a CTF very boring if, you can just, if one team can just make it so nobody can do anything. But, in general, space systems from an architectural level have, lots of vulnerabilities in them. And most of them are there intentionally, like Jason was saying, and they're built into them to, make the systems reliable, resilient, and recoverable. Because, in space, you can't get it back. And, you want to be able to, if something happens and something changes, you want to be able to maybe, change the software of the vehicle, 10 years down the line to do something slightly different or slightly better, right? And if you have any of that kind of stuff built in, there's inherent risk and security vulnerabilities that are going to exist.
Yeah, it's funny because in the competition, there's, we implemented some of the software from real space systems, like NASA core flight software, and just some of the services are like download memory, poke memory, just simple commands like that, and they make sense for a space vehicle because, like, if your space vehicle's behaving anomalously, right, you might want to know what's going on. So read memory. Is memory corrupted? Is one of these tables corrupted? Right. Likewise, let me change one of the parameters in that table. Right. Just send a command, poke the memory in the table, and change it. And those are things like in the cybersecurity community, like what? Why would you
Exactly.
Write directly to memory command? Like that's absurd. But they take for granted, I think, and I don't know that it's necessarily taken for granted. Probably poor choice of words there. But they implement these things for specific reasons, right? For like Logan said, it's resiliency, reliability, recovery. But and so that those are some challenging concepts for both the cyber, and that's why we kind of need cybersecurity community to work with the aerospace community, because they can bring into light, like, maybe poke memory shouldn't just poke all the memory. Maybe it should poke a certain memory addresses, and maybe you should have protected commands, or maybe you have some security guards or privilege levels and certain things like that, right? Introduce those concepts, and those concepts I'm sure are being introduced as people are looking into these systems, but that's just kind of one of those eye-opening things for me anyways that I thought was really interesting.
Yeah, isolating commands, separation of duties, authentication, and those types of things. So as we come up to the end of the conversation here, I wanted to maybe quickly touch on because what we've talked about thus far is kind of identifying weaknesses and exploiting them as part of the CTF. Do you know if there is any monitoring for these types of activities, and is that part of the CTF at all? Are you watching what the teams are doing and observing signs of potential malicious activity?
So we, as the organizers, we have built in our own instrumentation where we can, monitor what's happening in the game. We can see, to the best of our knowledge, what teams are doing. We just need that kind of stuff to be able to, even score the game and figure out who's winning. So from that aspect, yes, we have, that level of monitoring to understand, what's happening, which allows us, at least, also then go back and see, how did teams do what they did and, understand what happened.
Yeah, Logan, can you talk about maybe like space systems, the monitoring that, they have, like at the ground station level, like all the commands that have been sent to the vehicle, downlink all the data, recording that, capturing that.
Yep. So, I think, as systems have modernized and, all the, requirements to log everything have, slowly percolated their way into space systems. I think there has been, an effort to, at least like log the types of commands, the data going up to spacecraft, and and even capture like the raw binary, and that kind of stuff. So, even if something were to happen, after the fact, you could go and perform analysis and figure out what may have happened in like a link if like a command went badly or something like that. But in general, as far as like the actual systems. In general, it's been, it's hard to monitor, embedded systems, especially when they're purpose built and, running, older technology that's, space rated. So like, it's hard to do, real-time monitoring actually in space. So on the ground, if it's a terrestrial system, you can imagine that, most of like, the monitoring stuff is probably happening somewhere, you'd see in, normal kind of network systems. But, I think that the space community has been slower to adopt a lot of that stuff than, the commercial web community that, got, hit by, all the hacking and all that stuff so much quicker, and, learned their lesson much faster in terms of adopting those kinds of practices.
Yeah, they don't have, CISOs and things like that sitting on the vehicle watching every command on the bus, right? Like you might be able to have in a corporate network environment or something like that. Just because the data is precious for a satellite, right? Like downlink and uplinking data is a precious thing, right? So you want your payload, focused on that primarily. You don't want, like a cybersecurity person, just sitting there, right, poking at the vehicle all the time. One thing they do have though is they do have other vehicles the same class. They have satellite simulators and flat sats and things like that. So they have representative systems on the ground, so they can kind of replay their commands back to those satellite simulators and see how it should behave and compare it against the real vehicle. And there's a lot there that goes on. That's a whole domain in and of itself, right? As simulating these vehicles and so forth.
Super exciting. We didn't get to what's actually in a vehicle technology wise. So maybe you guys will come back and we can have another conversation on that. Before we go though, two things. One, there's Hackasat 4 is on the horizon. I don't know who wants to share that, and then maybe somebody, the other one, if you can share a final call to action for the more immediate one in a few weeks, Hackasat 3, how folks can join you. So who wants to share what's on the horizon for
I'll let Logan handle the Hackasat 4 one.
Sure. So Hackasat 4 is going to be the first CTF in space. It's going to be against a spacecraft that's launching next year called Moonlighter. This is going to be put on by the government. They're funding the launch of this spacecraft, and the competition for Hackasat 4 is actually going to be conducted on board real spacecraft in space. So the teams that are the finalists for the Hackasat 4 finals next year will have a very interesting problem and competition for them to play and go up against.
That's super cool. Super cool. So that's out there, 2023. And Jason, more immediate. How can folks connect with you for?
First and foremost is go to www.hackasat.com. That's going to be the definitive source for all the information. I just went there myself, and there's a countdown to the final event, which is at 21 days, 19 hours, 13 minutes, and 36 seconds. So, and then obviously, Hackasat, we have Twitter as well, and so you can check out our tweets for live event competition, and that's going to be the best way for spectators to get involved. There's 8 teams. 8 of these teams are fantastic. We've watched a lot of these teams over the last couple of years now compete in this competition and just surprise us as the organizers. Do some amazing things. There'll be live streams that'll go on during the event that will be posted, so people can get that. I believe that gets posted to YouTube. And we go into detail and talk about some of the competitions elements that these teams are solving and some of the unique things that they're doing. It's really just some very interesting stuff. And you can look at some of the stuff we did previous years to get an idea of just what's in store for these teams and what's coming up. But the definitive source is our website, so www.hackasat.com, and it's only 21 days away now. And so I'm really excited about it. I'll be out there with the guys and it's always a fun ride. It's an interesting 36 hours, I think, is how long the competition is. And the teams they're all probably getting itchy and preparing and all thinking about it, because it's, they put forth a lot of effort for this competition. There's a lot riding on it. And these teams, like I said, are just truly fantastic. Some of them, 50 players are involved in some cases, and it's a sight to see for sure.
I love it. And sounds like there's plenty of room for spectators to participate, even if you're not going to be behind a very important keyboard during those 36 hours. And I have to say, there's a ton of resources on your site as well. Yeah, Jason, Logan, it's a pleasure to chat with you. And congratulations on the 3rd anniversary of this event, and exciting things coming with Hackasat 4. So thanks for joining us here, and for everybody listening, as noted, there'll be links in the show notes to learn more about the event and connect with Logan and Jason if you want. And of course, we'll continue to have more conversations on this topic and others as we continue to redefine cybersecurity. Thanks, everybody.
Thank you, Sean. Thanks for hosting us.
Thank you, Sean.
Asgardio by WSO2 is a developer-focused identity and access management solution. Offered as Identity as a Service, or IDaaS, Asgardio by WSO2 creates seamless login experiences to your apps in minutes.
Imperva is the cybersecurity leader whose mission is to protect data and all paths to it with a suite of integrated application and data security solutions. Learn more at imperva.com.
We hope you enjoyed this episode of Redefining Security podcast. If you learned something new and this podcast made you think, then share ITSPmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.